In our previous labs, we had set up computers so that we would have multiple computers on the same subnetwork. For example, we might put everything on the 192.168.0.0/24 subnetwork using the subnet mask 255.255.255.0. However, we introduced subnetting where we would break apart one big network into several smaller networks. Well, how do we move data between different subnetworks? Well, we need routing. So we have to set up routers. We're going to introduce that piece of hardware today. Now there are three ways that we can add routes, essentially teach our routers how to do routing. We can turn on a router interface and configure it. That will add an entry into the routing table. We can add a route manually. This is called a static route. Or we can configure routers to exchange information between them. This is called dynamic routing. We'll use number 1 and number 2 today in this exercise. So there's a bunch of hardware that we require. We need to boot everything up, reset all the configurations. Resetting the routers, the process is the exact same for the switches. Same commands, same everything. Okay, so the next step is to cable the network. So on network devices, now we've got R1 and R2. These are our routers. So I'm going to make sure routers is selected, and we are going to use 1941 routers. That's just the model number. I'm going to add 2 routers. I'll label them R1, R2. You can think of these almost as separate buildings. So R1 would be in building 1. R2 would be in building 2. So each building essentially has a router and a switch. We need 2 switches, so I'm going to make sure network devices is selected, click switches, add 2960 switch and a 2960 switch. This switch isn't going to do all that much in this exercise today. In best practice for flexible network design, typically you're not plugging computers directly into a router. Typically you plug your computers into a switch and then you plug switches into your routers. So we're doing that here. Best practices. S2. We've got 4 computers, right? Done this before. Computer A, computer C, computer D, computer B. I realize that order might not make sense. This is if you happen to have less than 4 group members. If there's just 2 of you, you would only have to do computer A and computer B, for example. Computer A. Oops, daisy. Computer C. Computer D. Computer B. Now I'm just going to put a text box here. 168.0.5/24, and the default gateway for this one, we haven't needed to use the default gateway yet in our labs. Today we do have to. 192.168.0.1. Let's see, let's just copy and paste. So computer C is 0.10, but everything else is the same. Subnet mask is the same. Let's paste again. Computer B is 1.5. Computer D is 1.10. 1.10, but these default gateways will be 1.1 and 1.10. typically your default gateway is the IP address of the router interface that you're connecting to. So if we look at this diagram here, the default gateway for computers A and computer C is 192.168.0.1. So what is that pointing to? Well, if you look up here at our router, we've got this Ethernet interface. Its IP address is 192.168.0.1. So these default gateways essentially point to the router. If we look over here, connected to router 2, their default gateways are 192.168.1.1 for D and B. And that's the IP address of this Ethernet interface on the router, kind of the internally facing interface. So what that default gateway basically means is if computer B tries to communicate with a computer that's not on its own 192.168.1.0 network, it's going to send that information to the default gateway. In this case, that's this router, router 2 right now. And essentially tell that router, you deal with this, I don't know where to send it. And that router makes sure it gets to the correct location. All right, we're missing some stuff. Cables, for one. I'm not going to do these console cables. Instead, I'm going to do the straight through. So computer A will connect to F02. Computer C will connect to F020. Computer D will connect to F018. Computer B will connect that to F012. Got the PCs connected to the switches. Now I've got to connect F05 on this router, or on the switch, excuse me, to this router, to G01. I'll connect F05 again to router 2 to G01. Notice the colors. These are red right now. There's a reason for that. We want them to be green eventually, but for now, it's okay that they're red. Need one more cable. So this red line right here represents a serial cable that would be used to connect two devices. Notice that there's the DCE label here. That stands for Digital Communications Equipment. The other end would be labeled DTE, Data Terminal Equipment. Now, it does matter which end you plug in. You plug in the DCE side, it would typically be a cable modem or something that a service provider gives to you on the DCE side. And on the DTE side, that's going to be what plugs into your router, your server, some equipment that you own. In this exercise, we essentially, in air quotes, own router 1 and router 2. So it doesn't really, we could flip that DCE side, but we need it consistent. The thing about these DCE cables is that we have to set the clock rate on the DCE side, and we'll go through that in the instructions, but just make sure your cable is plugged in the right way. So if I want the DCE side connected to router 2 and packet tracer, I'm going to click the serial DCE and click on R2. Whoops a daisy, I forgot a step. If I remember back to our packet tracer crash course, what do I need to do? I need to open up these routers, power them off, drag my serial connection there, power that on. Need to do the same thing for this one. Fortunately, we don't make you bust out the screwdriver in our lab, in the cyber lab. Now that I've added those serial connections, now I can I see my serial 000, and now I see serial 001. Now we've got these loop back interfaces here. It looks like we should cable those. We don't cable those. LO0 209.165.200.225 255.255.255.224. Make sure to get that 24. We've got another one here, LO1. Its IP address is 198.133.219.1, 255.255.255.0. So these are loopback addresses. They're basically almost like pretend interfaces on the router. We are just using these loopback interfaces to test connectivity. We can pretend that these represent the internet. So that if computer C wanted to connect to our, in air quotes again, internet, they could try to ping that IP address and make sure that connectivity works. Okay, let's take a look here. Why don't I, you know what, I've made a ton of IP addresses here, 192.168.0.1. I'm just going to put all this on Packet Tracer. /24. Why can't I click in there? There we go. /24. Use that shortcut notation. And we've labeled almost everything, so why don't we go ahead and label the IP addresses for those. Serial connections to 10.1.1.1 2. Okay, so those are /30. So we haven't used that subnet mask very much in class so far. We are going to use it today. So it's a /30 subnet mask. So how many computers does this network support? Number 2 to the n minus 2. So they support only 2 interfaces on that network. So we've got number 1 on the left for router 1 and number 2 on the right for router 2. Okay, I think this looks good. So if you're doing this in the lab, you're going to have to reset all this equipment. Of course, because we're using Packet Tracer and we just threw this stuff onto our workspace, everything is reset by default. Takes a little bit of cabling. Notice that these are red. Nothing connected to our routers seems to be working, right? Before I scroll down, here's the question. How many networks do you see in this diagram? So pause the video and count. If this is difficult, it's difficult for most people. It's a critical question. If we don't understand how many networks are in this diagram, routing is not going to make much sense. So pause the video if you need to. I'm going to tell you the answer in 3, 2, 1. There are actually 5 different subnetworks in this one big network. Okay, so how do we get all 5? Well, we've got the first one. There's no order necessarily, but I'll start here. The first one, 192.168.0.5. We got 0.10 and we got 0.1. This is one network. 192.168.1.1. This is another network. Just think, if we line up these subnet masks with the IP address, we know the first 3 octets define our network. So we could call this the 192.168.1 network. This would be the 192.168.0 network. Now we've got this 2-computer network. on the 10.1.1.0 network. There's just 2 of them. And then we've got these 2 other IP addresses here that are on separate networks. So there's five different networks there. We know that just by looking at the IP addresses and subnet masks. All right, switch configuration. We are not going to actually touch these switches today. They're just kind of an intermediary between our PCs and the router. In theory, we could just plug these computers directly into the router, but not a best practice, so I don't want to teach bad habits. All right, let's go to the router configuration. Okay, so I'm going to, on both of my routers, I'm going to come to the CLI tab. It says continue with configuration dialog. Always type no there. Hit enter. So enable config T line con 0. Logging synchronous password class login exit. Enable secret Cisco banner MOTD pound no unauthorized ACCESS. Did I spell both those words right? Unauthorized and access? I think so. I hope you're clapping while watching this video. Now, notice that those commands are exactly the same as the switch configuration. No, I don't want to continue with the initial configuration. Enable configure terminal, con 0, logging synchronous. You should know what all of these commands do at this point, so I'm not going to explain them. Keep out. All right. So now there's some specific configurations. So for router 1, we want to change its hostname R1. For router 2, we'll change its hostname R2. Close R2 for a second. Now we need to configure the interfaces on the router. And there's something that we do here that we do not do on the switches. On the switches, we never assign an IP address to the individual interfaces, like F01, F02. Instead, we assign an IP address to the computers, and then the computers connect to the switch. However, routers are basically highly optimized computers that do routing really fast and really well. So each of these interfaces on a router, we have to give them IP addresses. So I'm going to use the command int g01, so that's interface, our gigabit Ethernet 01, that's what our switch is connected to. I'm going to give it the IP address 192.168.0.1, 250, I do not actually want to do that. Windows updates, love them. 255.255.255.0. So this syntax is different than Windows, it's different than Linux, it's specific to Cisco. It's just IP space address space the IP address you want space the subnet mask using dotted decimal notation. Hit enter. No news is good news. Now here's a key thing I need to do. I need to say no shut. So by default, all of our interfaces on our switches, when we just booted them up, the switch, they're all on by default. The router is exactly the opposite. All router interfaces are shut down administratively by default. So I have to say no shut. So look at my diagram here. Predict what's going to happen. All right, so all of a sudden that interface turns on, it's green, it's amber on the switch side as it negotiates that connection, but we're getting there, right? That's good. I'm going to come to interface S0/0/1. I'm going to give it its IP address. IP address 10.1.1.1 255.255.255.252. I'm going to say no shut. So what's going to happen here when I hit enter? Nothing. Well, the configuration change worked, but no lights changed. So why is that? Well, it's because router 2 is still down, right? We need both ends up for that light to come on. Now sometimes people have a question. Sometimes people just type the wrong IP address. So if I typed IP address 10.50.1.1 255.255.255.252 and hit enter, you might think, oh no, I've screwed up my lab, nothing's going to work, it's all broken. There's two ways to fix this. I can just run the IP address command again, and whatever I entered the second time will overwrite what I did before. So if you just made a mistake, if you made a typo, just run the IP address command. Again, problem solved. There are times though when you just have to erase that IP address. Start over. Like maybe you assigned the IP address to the wrong interface and you can't, like let's try this. 192.168.0.1. I already assigned that IP address to G01 and it gives me an error. It says overlaps with G01, right? So you get kind of stuck. Well, I can't just overwrite that IP address. I've got to fix it. Well, you can use the no IP address command. That's the erase it. So you may need to just configure your interfaces, say no IP address. If you mess them up, assign them to the wrong one, use that no IP address, then assign it to the right one. So what's this one supposed to be? That's what it's supposed to be. Okay, so that is good. Make sure you get that 252 at the end. You might have muscle memory saying 255.0 there at the end. Let's come to router 2 now. Interface G01. I'll pull this over so we can look at our diagram, see what happens while we type. IP address 192.168.1.1. Actually, before I do that, I'm going to run a command. Do show IP route. This is my routing table. Okay, and it's empty. There's a bunch of codes. Your router is always going to show you these codes when you run this command. And it tells me the gateway of last resort is not set. The gateway of last resort is basically your default gateway. Okay, so I'm going to jump back to the instructions now, and I'm going to give that G01 an IP address. IP address 192.168.1.1 255.255.255.0. No shut. Here's my diagram. Boom, this connection is going live. Now if I say do show IP route, all of a sudden I've got a single entry in my routing table. So just by giving that interface an IP address, I added information in my routing table. I have essentially told my router, hey, if you want to go to the 192.168.1.0/24 network, use the Gigabit Ethernet 0/1 interface. If we look at the codes here, we have C for connected, that's the network, and L for local. Local just means on the router itself. You can see here we have a /32 subnet mask, which is essentially notation that identifies a single connection. So that is the IP address of Gigabit Ethernet 0/1. Let's add our serial interface now. Int S000 IP address 10.1.1.2 255.255.255.252 no shut. So I'm going to run that. Boom, both ends are on because we've issued the no shut command on both sides of that interface. Now the thing I've got to do here is say clock rate 128.0.0.0. That's essentially the speed that these interfaces should connect on. So I'm going to hit enter. You won't see any change. Some people ask the question, well, how do I know what clock rate I should use to set? You'll always be told the clock rate. You won't have to do some special kind of math to figure out what clock rate to use. It'll just be given to you. All right, we've got these loopback interfaces on router 2. Those are fairly easy to create. We just say int LO0, make sure to get the letters and numbers right. IP address 209.165.200.225, and make sure to get that subnet mask right, 255.255.255.224. Okay, int LO1, IP address 198.133.219.1, 255.255.255.0. Now I'm gonna run do show IP int brief. We can see those IP addresses that we just assigned. So gigabit 01 has the right IP address. My serial 000's got the right IP address. I've got my loopback adapters. All that's good. Now if I look at my routing table, so remember the command, do show IP route. I've got 4 networks here. Okay, so I've got this 10 network, 10.1.1.0/30, 192.168.1.0/24. I've got the 198.133.219.0, 209.165.200.224. Though all of these entries now show up in my routing table because I've configured those interfaces. So I didn't have to specifically add those to my routing table. As soon as I configured the interfaces, my router stuck them there. So that's good. Everything looks good so far. So previously we said we had 5 networks on here in this whole big network. Which one is missing from my routing table? So pause the video if you need to think about it for a minute. I wonder how many people actually pause the video when I say that. Well, this router in this routing table knows about all of the networks except one. It doesn't know about the 192.168.0.0/24 network. It doesn't know about all those computers on the left, that switch, and the gig 01 interface on the left. That's the only one that is actually missing. Okay, so let's do some client configuration, then we can start to actually test connectivity. So computer A, we'll give it 192.168.0.5. The default subnet mask it recommends is good. Now we actually have to add the default gateway though, 192.168.0.1. Close that out, no need to click save or anything. I'll go to computer B, desktop IP configuration, 192.168.1.5. Subnet mask looks good. The default gateway will be 192.168.1.1. Close all that out. So we'll go to C next. Desktop IP configuration, 192.168.0.10. tab, subnet mask is good, tab. For computer C, the default gateway will be 192.168.0.1. And last but not least, computer D, 192.168.1.10. Subnet mask is good, 192.168.1.1. For my default gateway. Alright, so let's verify connectivity. So let's go to computer A. I'm going to try to ping computer C. Ping 192.168.0.1. Okay, reply, it worked. Now, can I ping... Oh, sorry, that was the 0.1 is the interface. That's my router. I can ping my router. That's good. I'm supposed to be able to ping my router. 10 is computer C. I should get a reply as well. Everything's good. Remember, if you're using Windows laptops, disable your firewall temporarily. Otherwise, this isn't going to work. This pings will be blocked. Let's do something. Router 1, I'm going to run the command do show IP route. So it knows about 2 networks. It doesn't know anything about this 209.198 or 192.168.1 network. It does know about the 10 network though. So let's see if I can ping those router interfaces. Can I ping 10.1.1.1? Yes, I can, because my router knows about it. 1.2, what do you think? It's not working. Why would that one not work? My router knows about that network. The packet's probably making it to router 2, but it doesn't know how to get back. We'll fix that. Don't worry. So what else is going to fail? Ping 209.165.200.225. Not going to work. My router just doesn't know what to do with it. That network is not in its routing table. So let's see, computer D, who can it ping? Can it ping 192.168.1.5? Before you hit enter, just think every time, should this work or not? Should computer D be able to ping computer B? Yes. So should it be able to ping its router? 1.1. So you'll notice I didn't type that super fast. I've just pushed the up arrow key to get my last command. You can push up and down to cycle through your commands. Should I be able to ping 10.1.1.2? Will that work? Yep. What about these loopback addresses? Ping 209.165.200.225. Should that work? Think about it. Yes. What if we ping 198.133.219.1? Works. What about if I try to ping 10.1.1.1? 10.1.1.1. No, it's not going to work. It's failing. I'm just going to Control C to stop it. Ping. I'll try to ping computer A. 192.168.0.5. Destination host unreachable. Yeah, that doesn't know what to do with that. Okay. So not all of these computers are able to communicate right now. So we need to fix that. We've run show IP interface brief and show IP route. You should know those 2 commands. The output of do show IP int brief you should understand what the interface column means, what the IP address column means, and the status. Those are really the things that you want to look at. For do show IP route, you want to be able to interpret this and read this. It just takes some time. The first time you look at a routing table, it just looks like a big mess of numbers. But try to connect these IP addresses and these subnet masks to the information in your network. Just looking at a routing table, you can almost build an entire network. This tells you tons of information that you need to know once you get familiar with it. Looks kind of like a mess, but take some time to study it out. All right, we are going to configure some recursive static routes. Now, computer A could ping 10.1.1.1, but it could not ping 10.1.1.2. So why is that? Well, that message, when it got to the router 1 sent it off to router 2. But router 2, it got the message from a network it does not know about, right? So router 1 doesn't know about the 192.168.1 network, and router 2 doesn't know about the 192.168.0 network. It's kind of like, imagine if I send a letter to Uzbekistan, and the post office here in Marquette, they know where Uzbekistan is. It's a big country, right? So they think of the Marquette post office as router 1. They send it to Uzbekistan, router 2, but the people in Uzbekistan, do they know where Marquette is? If I just put the city of Marquette there, well, Marquette is much smaller than Uzbekistan. Like, they don't know how to send it back. They are not aware of the city of Marquette, hypothetically. Let's assume they don't have Google, and they can't just look it up online. That's kind of the situation we have here, where these routers, they don't know the information about the route. So we are going to add a route. So for R1, we're going to come to the config. Right now, I'm in config if, so how do I change that just to get into regular config mode? That's right, I just type exit. So I'm going to run that command in the lab guide. IP route 192.168.1.0, 255.255.255.0, 10.1.1.2. So what does this mean? Doesn't really help if you just copy that command if we don't know what it means. We are saying add an entry to our routing table so that if this router receives any packet that is going to the 192.168.1.0 network with that subnet mask, send that packet to this next hop, 10.1.1.2. So if router 1 gets a packet destined for computer D, for example, it's just going to send it to that IP address, 10.1.1.2, which happens to be connected to router 2, which knows all about that network. So we hit enter. Now I'm going to run do show IP route. Now I've got a new entry in my routing table with an S, meaning it was created statically, meaning I did it all by myself. Did it manually. So now I'm going to open up computer A. And now let's see if my ping, I'm going to try to ping computer B. I think that's the IP address for computer D. No big deal. 192.168.1.10. Oh no, is networking broken? Still not working right. Well, my router knows how to get information to the 192.168.1 network, but router 2 doesn't know how to get information back to me yet. So we need to fix that. So we are going to, excuse me, we're going to fix that using a directly connected static route. There's two ways to create static routes, either using the next hop IP address or using the interface to shove that message out on. Okay, let's see, Cisco, that's class. That one is Cisco. Just keep typing Cisco or class if you forget, it's okay. Configure terminal. So this is router 2 now. I need to teach it about the 192.168.0 network. So IP route 192.168.0.0 255.255.255.0 S0/0/0. Okay, so this is similar to what we did before, but we're using a different type of static route. This is saying, okay, router 2, if you get a packet going anywhere on the 192.168.0.0/24 network, send it out on the serial interface 0/0/0. We could have used the IP address instead of S000. We could have used the IP address of the receiving interface, so 10.1.1.1. Instead, we are using the name of the local interface. So we run that. This is fine. Ignore that message. Do show IP route. And now we've got that S. We've got our new static route connected there. Just need to highlight 1. That's our static route. So I'm going to bring up computer A again. So that ping failed last time. What about now? Now it's working. Now computer A can ping computer B, even though they are on different networks, because we have enabled routing. So we had to have routing working in both directions for those two computers to communicate. That's a key idea. It's got to work both ways. Router 2 has to know about router 1's networks, and router 1 has to know about router 2's networks. So everything is good. But now, let's see, computer A, computers D and computers B. Here's a question for you. Should any of their pings to any IP address in this network fail at this point? Should anything fail? No, nothing should fail, because router 2 knows about every network, all 5, 192.168.1.1. That works. Successful reply. Ping 209.165.200.225. Reply works. Ping 10.1.1.1. Yep, it works. Ping 192.168.0.10. Okay. I was nervous there for a second. Sometimes the first ping might fail, that's okay. As long as the subsequent ones work, everything's fine. So B and D can ping everything. How about computer C? Should computer C now be able to ping everything? I can ping 10.1.1.2. Got a reply. Ping 192.168.1.10. Get a reply, so that's computer D there. I can ping computer A. It doesn't even have to go over the router to get there. But now we've got ping 209.165.200.225. Is that going to work? No, it's not working because we didn't tell router 1 about those two networks. So we need to fix that. So on router 1, create a recursive static route. So that's using an IP address to the 198.133.219.0 network. So I've given you the syntax there. So see if you can do that on your own. I am going to do that for you. IP route, right? So we got IP route destination network. So that would be 198.133.219.0. The destination network subnet mask. So that for that one, it is 255.255.255.0. And the next hop IP address. So the next hop for this router to get there would be 10.1.1.2. Okay. No news is good news, right? So let's, on router 1, let's create a directly connected static route to the other network. So the syntax was there, IP route. Destination network will be 209.165.200.225. The subnet mask is 225.225.224. And the exit interface. So what is my exit interface going to be? Router 1 is going to shoot that out of S0/0/1. We can ignore that error warning message, not really. Inconsistent. IP route 209.165.200.225. So everything. Oh, whoops. I made a little mistake. That network address is 224. I accidentally put in the IP address. You don't want to add set the IP address here with this route command. You want the network address. Okay, fix that. Good. Disaster narrowly avoided. Do show IP route. So we've got a couple of these static interfaces, static routes defined. So let's open up computer A. Let's see if I can ping 209.165. Yep, it works. Go to the other one in my history. 198.133.219.1. Yay, it works. So I had to teach router 1 about 3 networks that were not connected to it. Now let's undo some of that hard work that we've done. On router 1, I am going to issue the command no IP route 198.133.219.0, 255.255.255.0, 10.1.1.2. And so that just deleted that route. So now that I could not ping that from computer A. No IP route 209.165.200.224 255.255.224 S001. So those will be gone. Do show IP route. Now I only have one static route left, and that's going to computer B and computer D's network. So there are a lot of networks out there in the world. I don't want to necessarily add a static route for every single one of them. So what I can do is I can configure a gateway of last resort. This basically says, I will type the command IP route 0.0.0.0 with the subnet mask 0.0.0.0 S0/0/1. This is a weird syntax. It might not make any sense, but this is just the convention. This says if you, Mr. Router or Mrs. Router, depending on your router, if you get a packet destined for a network that you don't know about, it doesn't match anything, well, send it out through your serial 001 interface. We can ignore that unhelpful message. So now if I run do show IP route. Got my default, my gateway of last resort there. So I don't specifically, in that routing table, I don't have 209.165.200.225 there. However, if I ping it, I get a reply. It's working. So that's good. I could connect, 500 loopback adapters there, and I wouldn't have to change router 1's configuration to add static routes, because anything that it doesn't match in its routing table is just going to send out through that gateway of last resort. It's like your last hope. If I happen to find anywhere specifically for that to go, it's going to send it there, and it'll work just fine. So check your pings. Everything should be successful at this point. Make sure everything's working. As long as your routing tables are set up correctly, your interfaces are set up correctly, maybe I'm simplifying it too much. As long as everything is correct, it should be correct, right? Very circular. So you should be able to, at this point, display the routing table on a router. So that's the show IP route command. Enable router interfaces and assign them IP addresses. We've gone over how to add a loopback interface on a router. It's very straightforward. Describe the two methods for adding static routes. Describe the benefit of directly connected static route over recursive static route. I didn't talk about that. It is in the lab. A directly connected static route is technically faster because the router does one lookup instead of two. With a directly connected static route, we tell the router which interface to use. With a recursive static route, we tell it what IP address to use. So if we give it an IP address, we say, okay, router, if you need to get to the 192.168.1 network, use the 10.1.1.2 next hop IP address. Well, then your router has to ask itself, okay, but then how do I get the 10.1.1.2? Oh, I have to use serial 001. Not probably a huge difference, but technically directly connected static routes make the router do less work. So we've added static routes to the routing table. We've used the gateway of last resort. We've deleted static routes. We've set the default gateway on our computers here. And we've used ping to verify connectivity. All right, there was a lot of stuff that we had to configure there. Hope everything is sinking in, making sense. Always come to class with any questions. Thanks.